All right, we are live. So, welcome to MathReps Monthly. It is February 2022. Yay! So here we are. We're just going to be talking today about. Hope you can hear me. So, it looks. I'm not sure if. All right. Hopefully that's working. Sorry. So today we're going to be talking about frayering your math class. So we're going to be looking at how you can use the Frayer model with math vocabulary, which can be really difficult for students. It can also be difficult for those ELL students. They need a little bit of extra support sometimes, and actually most students need a little extra support. We use things in a different way. When we are, using math vocabulary than we do in maybe other ways, linear things like that. I popped out on my screen. Um, let's see. Also, we're going to be looking at how you can problem solve with different strategies, which is probably my favorite way of using the Frayer model. We're also going to break down complex problems because so many times we have complex problems, especially when it's a word problem, two-step word problems, kind of like working out what you need to do. Sometimes using that with the Frayer model is really, really helpful to students. So let's get started. All right, so those of you who are not familiar with a Frayer model, it simply looks like this. It's a really simple chart that looks like this. So in the center, you can put a word, a phrase, a word problem, or just a regular problem specific to math. In the center here, you can, for vocabulary purposes, write the definition, write some facts or characteristics about it. And we'll see an example of that in just a minute. I did do this a few years ago with my fifth graders. We'll look at some examples and then non-examples. And so this helps students to understand and identify what each term is. Oh dear, I am not. Hello? So I realized that my microphone was not plugged in. So I am not sure how this is going to go. So let me go back. Apologies, my friends. And I'm going to go ahead and just double check my audio on this. Nope. Yep. So there we go. So I apologize. So I'm starting over again. The audio is now going. I don't know how it became unplugged. So again, we're going to be looking at math vocabulary. We're going to be looking at problem solving with different strategies, breaking down complex problems, and other things that you might be able to do with a Frayer model. So again, this is a Frayer model. In the event that my microphone wasn't working before. And here we have the Frayer model, and it just has 4 quadrants. You can have more quadrants, you can have less quadrants. It depends on what you want the students to do. I've seen teachers have a meme, or they put in a GIF of some sort to kind of represent their thinking. So you have the definition, facts and characteristics, examples, and then they write non-examples. And like I said, we're going to be looking at some examples of these. So the first one that we're going to be looking at is math vocabulary. So in the math vocabulary, let's look at this. So this is a really great example. This is a 5th grade example. Several years ago, I did this, and this was in a collective slide deck. So my students were in a collective slide deck, and they were, each student was assigned a word. So they were able to look at the word, find the definition, and do what they needed to with it. So they did definition, what are some facts and characteristics. So looking at this one, this is standard form, which is an NBT standard, of course. And here we have the standard form, what it is, the definition of it. Were they allowed to look it up using Google? Absolutely. Were they allowed to, kind of copy and paste it? Not really. They had to put it in their own words. They did do this. They could find an image that was online to show standard and expanded form, or show like what makes it a standard form. I love this one, standard form, expanded form, and the student just kind of came up with their own example. And then they came up with this really wacky non-example for themselves. So I really liked that. In this next example, I really like this one too. The student wrote down what they felt the hundredths was, and so they recognized it as a place in the place value system. They showed what the characteristics were. It's less than a whole. I love that they wrote that there as well. And then they gave an example, they pointed to it. And then they gave the non-example of that this is in the tenths place. So you can see if you have an entire slide deck with all of the different vocabulary that you're using in either a unit or within the standards or within a series of units that you're studying, it really helps the students to, focus and hone in. And if they don't know what standard form is, so say they're using a MathRep and it says use expanded form and they forget what expanded form is, they have an online dictionary that they've all gotten together and they've done it. Did I check it to make sure things were accurate? Absolutely. Sorry, felt a little Elise Myers on that one. So I'm really into Elise Myers. She cracks me up. Anyhow, I digress. Never mind. Sorry, my brain went somewhere else. And so I'm just going to try and keep these MathReps monthly a little bit short. Recently, they've been a little bit long, and I just kind of want to shorten them up to kind of give you a little bit of an idea. So this next one we're going to be looking at is problem solving with different strategies. This really is my absolute favorite way of doing this. And let's see. So I'm going to go ahead and move on. So this is a first grade example that I did last year with a class. And so in the center here, you can see that we have the word problem ready for them to go. So this was given to them. This was used, I used Jamboard with the class. They had touchscreen computers. And so they went ahead and they looked at it and we did it together as a class to get them started. And let's see. So they read the problem. I'm not going to read the problem for you. You're an adult. And we did it together. So at first we started circling and some of the kids didn't like that. So that's why there's sticky notes here as well. So they didn't like drawing because some of them just didn't have a lot of the dexterity. So this student did, but a lot of them didn't. So that's why there's two different ways of doing it. So we drew that there are 3, and then we drew a line to represent. That's how many we have. We need to find out how many more to get to 10. Looking at this now, wouldn't a 10 frame would have been beautiful for this, right? Like they could have done some 10 frame work on this one too. So you can replace the draw it or the tape diagram with one of those other methods. And the sticky note just represents we had the 3 and then they put in 7 more, and those are just periods. We also use the tape diagram to show that we know that there are 10 altogether. There are 3 here. How many more do we need to add to get to that 10? How many cookies did she need? I personally struggle with a number line, but you know what? Not all students do. So some students really gravitate towards this. So that's why it's important for us to show solving problems, because just because it works for me, like the tape diagram might work for me and the draw it method might work for me, the 10 frame might work for me as well. This might work for somebody else. So it's super important that we make sure that all of our students are represented, and we try and show them different ways of doing it, because the more ways they can do it, the more they'll understand it. So we had the students talk and said, okay, so you have 3, 1, 2, 3, and then we circled the 3. And then we counted how many jumps did it take to get over to that 10. And of course it was 7. And finally, we had our number bonds here. And this is just a big deal in first grade. So we made sure that we hit the number bonds. But I think I do this again. I think I'm going to add in a 5th box. Like I said, you don't just have to have 4. I think I might add in a 5th box and put in a 10s frame so that we can solve it with a 10s frame as well. Here's a great second grade example. This is a more recent example from a second grade class. And excuse me, the teacher wanted a related fact. So she wanted that related fact. Excuse me. So we made sure that we put that in there. So this was based on the teacher's needs and what she was looking for. We then did the base 10 method. I like to shout out to Chris McKee. She is a second grade teacher in my district. Her, instead of doing dots, which can get kind of messy, they get kind of scrunched together. It's hard to tell when they've been crossed off or whatever. She suggested using an X because those X's will make sure that it's a little bit more defined so that you can see it. So we have the 73, we had the 48, we grouped them in 10, we regrouped, we grouped another set of 10 and regrouped. And then we saw how many we had all together. We had 100s, 2 10s, and 1 1 for 121. We also looked at the place value model as well. And so we did the 70 plus 3, 40 plus 8, and we did some of that adding as well. Now, the curriculum that my district has chosen uses something called working form. Please note that this is not a second grade standard. This looks very much like the standard algorithm. The standard in second grade simply states that they need to be able to do these models and see what the number representation looks like. So they don't necessarily need to be able to do the algorithm because addition with an algorithm is a third grade standard for those who are unfamiliar with that. And so this is what the teacher wanted. This one was most recent. This was last Friday. No, 2 weeks ago Friday. I didn't go in that class last Friday. So 2 weeks ago Friday, another second grade. And we did it on, as you can tell, paper, and we used pencil. I was here for it. So this is what the teacher wanted. So again, we're just going with what the teacher wanted. And so 67 subtract 32. And then I put the 67 there for the students, and we talked about jumping backwards by 10, which of course is a standard in second grade. It's also, it is a standard in second grade. I think it's a first grade standard, although I think in first grade, they have to do it on the 10, so 10, 20, 30, 40. And so we did that, and we got 35. So we showed it with the number line model in this case. Over here, we have the 1s and the 10s. The teacher in this case showed them how to do small boxes for 1s. We went with it. Again, this is what the teacher wanted. This is what her students are used to. So we go for it. She also did not want anything that was with regrouping. So that's why we don't have any regrouping in this particular model. We also did the base 10 model where we have the 60 plus the 7 and then 30 plus the 2, and we subtracted from there. And again, you'll see the working form that my district uses. And finally, yay, breaking down a complex problem. So I really like this one too. I think my favorite is different strategies of solving a problem. And then my second favorite really is breaking down complex problems, because so many times our kids don't stop and think and slow themselves down. And doing something like this really helps them to slow down. Now, this is going to be a little bit crazy banana pants. Yep, I said that. So you'll notice that this is 1 over here in the top right corner, 2, 3, 4. In math, these are the general, this is a 7th grade example. So in math, this is the actual quadrants how they're numbered in math, right? When they use the number line. Numbers. So Jeremiah Roosh, the co-author of Edge Protocol's Math Edition, did it this way, and this is where I got it from. He does it this way. I think it's brilliant. I even do it this way starting in first grade. They don't need to know why. I just say, when you get into older grades, this is what they do. So they feel all good about themselves. And it just gets them kind of used to doing it this way, because math it's so different from reading where we go. In reading, we go from left to right. In math, when we add and subtract, we start in the ones place. So we go from right to left. These quadrants, we go from, upper, right, and so on. So in this one, you can see that there's a word problem that's in the middle. And so the students have to kind of break it down. So the student broke it down into a thought process, which I thought was interesting.
And this also, if you're like, I recognize this example, yes, you probably do. This is actually in the framework. So the teacher must have, like, I'm not sure if they worked it through it with them. I would have done it a different way, but would have come up with the same answer. And that's the other great thing, is that you can have students like reflect on how they did it in their thought process, and how other students would have done it differently. So you can see that they've kind of set up their ratio here. Just like, I don't know, is it going to be equal to this? Because that is the essential question. And so then they start working it out to, multiplying it by 7, they get their answer. And then they're going to multiply it by 2 because, and it says it over here, because half of 14 is 7. And so half of this will give them the cost. I love that the N is put here as well. And you can see the student wrote all of their work down. Again, this looks like it's on Jamboard, and it's lots of touchscreen in my district. And then finally, in quadrant 4, you can see that the thought process was written out a little bit more. You could have students also write the thought process in each one of those quadrants to see what their thinking is throughout the entire process. It's really your choice. There are so many different ways that you can use a Frayer model. It's so versatile. It's wonderful. So I hope you'll try it out. And it was much shorter MathReps monthly today because, well, we don't have a whole lot of time. So have a good one. I hope this was helpful. Please feel free to reach out to me. You can reach out to me on Twitter at Noah Techie, NowaTechie. I'm also on Twitter. I just said that. TikTok, the Facebook pages. So have fun and happy frayering your math.